Okay, so now we're recording. So we're going to look at the first problem, and I'm going to go through how you would solve a problem like this on tomorrow's test. So the first thing that I'm looking at here is this a function. And what Mr. Bodley talked about on those first day of notes was he said that the way to tell if something's a function is to use what we call the vertical line test on a graph. That means I can take my line and I can draw a straight up and down line anywhere on this graph. And if I only hit one point on the graph, then this is going to be a function. So all of those lines that I just drew are a bunch of vertical lines. So, undo that. So since I drew all of those vertical lines, I can see that those vertical lines only crossed the graph at exactly 1 point each. So since these vertical lines only ever crossed at 1 point, this thing we would say passes the vertical line test. So when it asks, is it a function? My answer is yes, this thing is a function because it passes the vertical line test. I didn't ask you to explain it on the practice test. All I asked for you to do was to answer the question. Okay, so again, if you've got any questions, you are welcome to ask it in the chat function. Looks like we got a question down there. Can I still take it? I can't find the test. So the test is not available yet, Asa. The practice test was available yesterday. And yes, you can still take it. I'm gonna be going over every question on it. So you decide whether you wanna watch this before or after you take your practice test. All right, so that was question number 1. I'm gonna slide down to question number 2. Now we're asking, with a table, is this thing a function? So the way that we're gonna tell if a table is a function is we are checking to see if every input has exactly one output. So our inputs are over here on the left side. Those are our X values. So if I didn't say input up there, I might have just said X on a normal problem, and that's okay. X and Y are input and output. So here I'm checking every input. We've got 0, 7, and 10. So we're gonna check to see if all of these inputs give exactly one output. So when you have an input of 0, the output is 3. That's great. Here's where the problem happens. All right, there's another input of 0, but we already said 0 had an output of 3, and this 0 has an output of 5. That means 0 has 2 different outputs. So it's asking if this is a function. The answer is no, because 0 has 2 outputs. Now, something really important I want to talk about here, the only reason this isn't a function is because 0 has 2 different outputs. So if 0 actually went to 5, and then the second number, or excuse me, it went to 3, and then the second number instead of 5 was 3 again, that would actually fix this. That would make this back into a function because 0 goes to 3 and 0 still goes to 3. If you remember back to earlier in the school year when me and Mr. Bodley were going over functions, we said that a function can always be thought of like a vending machine. So you're thinking about the input, that's like the thing that you type into the vending machine. So for example, I might push A7. When I push A7, there should only be one sort of candy bar that comes out. I don't want a lottery or a mystery on what candy bar comes out. That's how these are working. When you put your input in, you should always know for certain what's going to come out. So since this one said 0 could go to 3, but it could also go to 5, that makes it not a function. Now, another thing I want to point out, it didn't happen on this, but it might happen on other problems, is if we had this table, oh, this is looking real great, and let's say we had 2, 3, and 4, and let's say 2 goes to 0, 3 goes to 0, and 4 goes to 1. I'll sometimes ask you if something like this is a function. So we're gonna follow the function rule again, where we're checking to see, does every input give exactly one output? Well, if 2 is my input, 2 always goes to 0. If 3 is my input, 3 always goes to 0. Thank you for the person who answered it in the private chat. If 4 is my input, it always goes to 1. So if this were a vending machine, I type in 2 and I get out, what's something that you get out of a vending machine? Snickers. And I type in 3 I could also get Snickers from a different button. That's okay, because when I pushed 3, I still knew I was getting Snickers. And then let's say I push 4 and I get a Gatorade. Great. But you've seen vending machines like this where multiple buttons give you the same thing. Just like at Costco, or even like at Riverview next to the lunchroom, there's the water vending machine where it has like water, 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 apple juice. That's okay. If 2 inputs give the same output, it's totally fine. Thank you for whoever said Twix. I actually don't like Twix, but that's okay. All right, let me clear that. So that means that because this had a single input giving 2 different outputs, that was not a function. Okay, so hopefully you found these ones to be really easy. If not, then listen up, because you're gonna think it's really easy after we talk about it. So I am going to talk about where it says f of 7. Remember, I told you inputs are the x values and outputs are the y values. So right here where it says f of 7, it's always going to be f of, oh, this is going to be really splendid handwriting, f of the input, and I would write this on a sheet of paper if you don't have it already. F of the input equals the output. I hope you know I'm doing this with a mouse because I love you so much. Oh my gosh, that was way better than I thought it was going to be. So f of the input equals the output. What does that mean? It means that whatever is inside the parentheses is going to be your input or your x value. So if 7 was inside the parentheses, I have to find 7 on the input side and figure out what is the output for 7. So when I look at that, 7 is across from 7. So that means that when I'm looking for the answer, the output would be 7. Okay, so remember, input is the thing in the parentheses, that's your x value. Output is whatever comes after the equal sign, that's your y value. Okay, so the second one, they did not give you the input. They gave you the output. I say they like I didn't write it. I did definitely write this one. Okay, so 5 is the output. That means I go to the output side and I'm going to find 5. So let's use this. Let's see. So what's across from 5? You can type it into the response, by the way. That's why you are allowed to click the chat thing on the bottom. I'm the only one who sees your responses. Unless you see them too at the bottom, I can't really tell. Okay, so, oh, I gotta switch it to drawing. Okay, so that's right here. The input has to be 0 because it's the input across from 5. So I just select 0. Great. Okay, again, this input output stuff inside the parentheses, that is something that you are going to want to put on your note card or on your paper. This thing right here is good information. Let me outline it in a beautiful color. I would have this on a note card or on my paper, and I would probably even write next to it number 3 so that I don't forget when I'm taking the test. Oh yeah, number 3, I've got to use that input output stuff. Okay, it actually probably is going to be useful on number 4 as well. So let's go to number 4 and we'll look at that one. If you just joined us, we are going through every problem on the practice test. Ask questions. You can open up the chat on the bottom. When I ask you questions, you're welcome to respond inside that chat. Okay, so on number 4, you're going to have a table. I'm going to give you the formula for the table, and I'm going to have a question mark somewhere inside the table. And yes, Asa, I can email you that after. I can at least tell you about that after. So on the input side, I've got every single number, but on the output side, I'm missing this one right here. So I'm going to use this formula. I know from what we said before that it's going to be f of the input equals the output. So let me get this. I'll write this one in regular color. So I am going to be saying f, but I actually have to find the output. That means I need to figure out what the input was across from this. So the input here was 2. So that means I'm doing f of 2. And I want it to equal all this stuff, but instead of x, there's going to be a 2 in that place. So I start with the -2 because that was already in the formula, but instead of x, remember, I've got to input that 2. Then I've got plus 2 on the end. Hopefully you all have a functioning calculator or a functioning wonderful brain inside that giant head of yours. -2 times 2 is -4. And then I add 2 to that, and I get -2. So f of 2 equals -2. I'm not sure who 0391121 is, but thank you for giving me the correct answer. Okay, so this is a problem where you actually have to type in the answer, and I'm pretty sure, oh yeah, if you try typing in something that's not a number, it's gonna say only numerical values are accepted. So don't be weird. Okay, so I'm gonna type in the answer of -2, that's all. Then I'm gonna move on to the next problem. Any questions on a problem like this? Give you a second to type in if you've got a question. If not, I'm gonna start clearing this and I'm gonna slide down to the next question. Okay, these graphs, I am willing to bet that this is where a lot of you have started having trouble on these problems. So let's look at this thing, and I'm gonna use my coloring feature to talk about the different sections. So it says, on what interval is the graph increasing? Ninth graders, on these graphs, we are always looking, oh, I meant to do coloring, we are always looking from left to right. So sometimes I'll see people who try to tell me that it's increasing here. If you try to say that it's increasing right here, you're working backwards, okay? You cannot have your arrow going backwards. So we need to look for increasing from left to right. So that would be only this section right here. That's the only section of the graph that goes uphill when you're moving from left to right. So where does that section begin? Well, it is right here. Now those numbers are 2 and 4. That means it starts increasing at 3. That's the only space between 2 and 4. Where does it stop increasing? Well, right, oh, this is not a straight line, right between 10 and 12. So it stops increasing at 11. All right, so let's check and see what this has. It is right there, from 3 to 11. Now I know there's like so much more we could have taught you and tested you on for the parentheses. I tried to not make that a part of what could confuse you. So for example, I could have said 311 and had like all these different parentheses things. I didn't want that to be the confusing part of this test. You need to get the numbers correct and you need to be using the x-axis. So it should say 3 to 11. Now there's another one that might have been tempting to click. Some of you might have been tempted to click 0 to 8. Now, that is a very common mistake. So why would someone think that it goes from 0 to 8? Well, let's look at this. Do you see how this spot where it starts is down here at the bottom? Well, that spot is technically 0 spaces up, and this spot is technically 8 spaces up. And that's a really common mistake. We do not use the y-axis for intervals with increasing or decreasing. There's actually only one time on all of these problems ever that you're allowed to use the y-axis, and it is for the range. So I would probably write that on a note card somewhere. Range is the only time you use the y-axis. You don't touch the y-axis unless it's talking about range for intervals. So since we said that it goes from 3 to 11 along the x-axis for the increasing, I'm going to click 3 to 11. Then the domain. Now increasing was just asking about a section of the graph that's going uphill. The domain is asking where does the graph go everywhere. So I'm going to switch to purple for my color quick, and we're going to find the domain of this graph. So where does this graph start? So the domain is everywhere that x goes. Okay, so all of my inputs. This graph starts over here. I'm marking that in purple. And then see how it goes all the way across the graph until you get to here.
I mean, why I've been in the wrong class the whole time.
Someone unmuted themselves. I forgot what I was saying, but hello to the person who started talking to me. So this thing starts at 0. And it ends, oh my gosh, I'm starting to feel old. I cannot read that. 24, 26, 28, I'm gonna guess that's 29. So it would go from 0 to 29. There were only 2 options. So if 0 to 29 is the domain, Remember, range, we use the y-axis. That's where we would go from 0. Oh, gotta switch it to drawing. That's where we would go from 0 to 8 was for the range. So the range is how far up and down it can go. The domain is how far left and right it can go. So since this one can go up and down from 0 to 8, we would say 0 to 8 for our range. All right, I'm gonna pause for questions there. Looks like we got one question. Will the test have similar problems to these? Yes, the test is pretty much these exact same problems, but just with different graphs to see if you can interpret it on a different picture. Killian asks, can't it have more than one? Are you talking about the range, Killian? Can we have more than one range? Is that what you're asking? Okay, so Killian's question is really good. Yes, there can be multiple sections. That is if the graph is broken. So I believe, let me find one on here that's broken. Like this one, for example, number 9. Number 9, the range isn't technically broken, but the domain is broken. So on number 9, we would have to say from like, oh, hold on. We would have to say from this point to this point, and then separate it from this point to this point, and then this point to this point, and this point to this point. So Killian's question was, can you have more than one piece inside the range? Yes, and this is an example where you can have more than one section for the domain. Not the range on this problem, but this one would have 4 separate intervals for the domain. I'm not gonna write them all down because it's not actually part of this problem, but that's the idea. Okay, I'm gonna answer the second question that I saw there. Is the test on Canvas or the quizzes? Test is going to be on Canvas. It's going to be almost identical to the one I'm going through now. It's gonna have drop-down sections. It's going to have fill in the blank and different stuff like that. But can it have more than one when it's not broken? Good question, Killian. So when we go back to this one that's not broken, there's not going to be more than one range. There will always be one specific range. So, and domain. If it's not broken, if it's continuous, then you are going to have one continuous range or one continuous domain. Okay, any other questions on a problem like this? It's okay if you do have one, you can just type it in there and I will go back if we have to. Okay, let's go to number 6. On what interval is the graph decreasing? Then it's asking about domain and range. Then it asks about the maximum. Why is the interval 3 to 2? I'm guessing that was asking about the last, 3 to 11. Okay, good question. I'm gonna go back to this one really quick. Why is the interval for increasing from 3 to 11? So remember, it was increasing on that uphill section. So the reason it was 3 to 11 is we looked at where it started. And since it starts here between 2 and 4, that starting place is at 3. So we say it starts increasing when you get to 3 on the x-axis. And then everywhere down here at 4, it's still going uphill. 5, it's still going uphill. 6, it's still going uphill. 7, it's still going uphill. I'm gonna stop saying that because it's super annoying. But you keep going uphill, uphill, uphill until you get to here. And that is where you would tell whoever's listening to this mathematical explanation, it stops increasing when you get to the point 11. So that's why we say from 3 to 11. My phone's not on silent. Now it is. Okay, so I'm not sure if that answered your question, Asa. It stops going up. Oh, perfect, thank you. Killian, that was a good explanation as well. Asa, I'm glad it answered your question. Okay, so we're gonna go back down to problem number 6. And Mackenzie, I just answered that question actually, Justice. It is going to be on Canvas. It'll be just like the one we're taking. It'll be just like the practice test. So the test is going to be a link on today's assignment. When we're done with this review, I'm going to upload it to YouTube and I will put it in, and then the test will be available right after this. So if you're feeling really confident when we're done watching this video, you're welcome to go start taking the test. That's okay, Mackenzie. Okay, so on this picture, I tried to be not the worst, and you see how it's asking if it's decreasing? There's a reason I didn't ask you if it was increasing. Can you imagine why asking if it was increasing would be annoying on this problem? What do you notice about this graph that would make it difficult to talk about where it's increasing? Feel free to type in your response. On the last problem, I asked about increasing, and it was okay because there was one section where it increases. On this, there's not one section where it increases. There are two sections where it increases. So the reason I asked about decreasing is because when you go around here, there's only one section where it actually goes downhill. So technically, it's increasing, then it's constant, then it's increasing this whole section, and then the last part is where it finally starts to decrease. So from here to here, that's the only decreasing section. So let's figure out where it starts decreasing and where it stops decreasing. So first of all, it starts decreasing at this turning point, which is at 5. And then it's downhill, 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 until you get to this at 6. So I know that my decreasing interval is going to go from 5 to 6. Let's find that one in here. 5 to 6, it's the last option. Perfect. Okay, so now let's talk about the domain. Remember, decreasing is just a small section, increasing would be a small section, the constant space would be a small section, but the domain is going to talk about the entire graph. Where does it go along the x-axis? So let me clear out that decreasing stuff, and let's look at where the domain starts. This graph starts over here on the far left side. We'll keep talking about the domain. So the domain is saying how far to the right and left does the graph go. So if I start on this blue graph, I start at 0. And then I'm following along. See how the graph exists all the way to 1? And then the graph exists all the way to 2. And then it keeps existing. There are no breaks, no breaks, no breaks. We're at 4, 5, and we keep existing all the way until we get to 6. And then the graph stops existing. When I go past 6, there's no more graph. That means that my domain is everywhere from 0 until you get to 6 and everything in between. That was a really, really scattered drawing, so I'm going to take that off. So my domain is from 0 to 6. Everywhere from 0 to 6 along the x-axis. So using that same idea, the range is going to be where does the graph exist on the y-axis. So if I look at the y-axis, it starts at 0. And then do you see how the graph exists going uphill, still there, existing, 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 until it gets to this highest point possible. Where's the highest point possible? Well, right here at 40. And then it's okay that it goes back down again, that's fine. It goes back down all the way back down to 0, but it means that the lowest that the graph went in the y direction was 0, and then it touched everywhere in between until it got to the highest point of the entire graph at 40. And the reason it's going to be solid parentheses with these hard brackets is because it's a closed circle at 0 and a closed circle at 40. So you're going to see that it has hard brackets on the ends of it from 0 to 40. Okay, so that was all of our interval work. We've got the decreasing, the domain, the range, and then let's talk about the maximum. So the maximum on this graph is going to be the highest coordinate on the entire graph. So I can see that this dot right here is the highest point on the entire graph. So my answer is going to be me telling the directions for how to get there. How far do I have to move to get to that highest point on the graph? Well, if I start at 0, 0, I have to go to the right 5 spaces, up 40 spaces. There's my answer. 5, 40. And this one is an ordered pair because it's just a coordinate. We don't put brackets around it because it's not an interval. So 5, 40, right there. All right. If on this problem, I were to ask you what the minimum is, think about that. What's the lowest point on this graph? There's a reason I didn't ask for the minimum. It's possible, but there are 2 places that are the lowest points on this graph. So this problem actually has 2 possible minimums. One of them is 0, 0, and the other possible minimum is 6, 0. You're just telling me the point that's the lowest on the graph, and then the point that's the highest on the graph. That's how we find maximum and minimum in a graph. You're looking at the highest point for the maximum, and you just write down the ordered pair for where it is. And then the lowest points would be writing down the ordered pairs for where they are. Again, on this one, I didn't actually ask you to find the minimums, but I want you to be aware of it because it's going to show up on the test. Now, one more thing that I always keep asking is the intercepts. So looking at this graph, does it cross the y-axis anywhere? Of course it does. It crosses the y-axis here. So if I had to find a y-intercept, I would say that my y-intercept is 0, 0. That is my y-intercept. Now, that's only the y-intercept right now. If I were to ask about the x-intercept, let's do that one in blue. The x-intercept is where it crosses the x-axis. This is where it gets pretty wild. That's also an x-intercept. 0, 0 is one of your x-intercepts, but you technically on this problem would have 2 x-intercepts. Your second x-intercept would be over here at 6, 0. So again, I didn't ask you for the intercepts on here, but I want you to be ready to be able to figure out where the intercepts would be. So again, the y-intercept, there would only be 1 on this problem at the origin, 0, 0, because that's the only place the graph crosses the y-axis. But there would technically be 2 x-intercepts
audio
along the x-axis. Hey, Mr. Bodley, we can hear you.
Can you put stuff in the recycle that's got metal, or should I pull them all off?
I'll mute him. Okay, so let's go down to the, oh, I gotta clear this. Let's go down to the next problem. Okay, is this continuous or discrete? Ninth graders, that should be the easiest question on this entire test. Whenever I ask for continuous or discrete, you should be thinking, seriously? Because continuous means that it is one continuous graph the whole time. Discrete is going to have breaks within that graph. Thank you, Killian. This one is continuous. All right, so let's see. We've got continuous there. And then where's the graph decreasing? Remember, you're always going from left to right. So on this picture, I would say it starts decreasing and decreases, goes downhill all the way to there. This is the place where it stops decreasing. And where does it start decreasing? Over here on the left, that arrow says that this is going on and on and on and on and on and on, back to a place called negative infinity to the left. That is a really poor looking infinity sign. So where does it start from? It starts from negative infinity to the left, and it stops at 0. That is going to be our decreasing interval. Negative infinity to 0. Here's how I know it's negative infinity. When you're looking at a number line, 0's in the middle, the positive numbers go this way. So that would mean positive infinity is always going to be on the right side when you're looking at domain or when you're looking at intervals. And negative infinity would be when you start going in the negative numbers forever in that direction, because you can imagine this graph is going to keep going backwards. So it starts at negative infinity, then it goes downhill till it gets to 0, and then the increasing interval is going to be over on the right side from 0 up toward infinity. So I would say 0 to infinity. You'll notice that there's a hard bracket on 0. I don't know, I stopped being nitpicky on that one, but I did put a soft bracket on infinity because you can't ever actually reach infinity. All right, I'm gonna talk about the domain. The domain, like we said, is everywhere that x can go along the x-axis. So that's saying my graph exists at 0, remember. How far back does my graph exist? If I were to go back to negative 10, would I still have a graph up above it? Yeah, because this arrow says it goes on forever in that direction. So if I was at negative 5,000, I would still have a graph above it. So that's why it is going to be negative infinity in the left direction. When you have this back here, my domain goes back as far as negative infinity. Then my domain exists all the way to 0. Then it keeps existing to the right until you get to positive infinity. So there are no stops, which is why this is going to be one continuous movement. All right, so that one was the domain. It is negative infinity to positive infinity. There were only 2 options there. So let's talk about the range. Remember when I told you on the last problem, I circled range and I drew these little things outside of it? Do you remember what I said about range? There's something that's only usable when we're talking about range. We said that range is the only time you are allowed to look at the y-axis for your interval. So I'm going to look at the y-axis for my interval for the range. All right, let's get this thing drawn on here. What's the lowest on the y-axis that my graph goes? Down here, -3. I kind of covered up the 3 when I did that. Let's just try that one more time. -3, that's the lowest that this graph goes. And then if I start going up, you might be tempted to say, oh, the graph starts at or stops at 3.5. Not true. Those arrows mean that this graph keeps going over and up forever. So that means it goes up to +infinity for the range. So it starts at -3 down here, and it goes to infinity up there. I don't know why I drew it like that, kind of to get you the idea that it's along the y-axis. Okay, so down here, it would be from -3 is the lowest it could go, +infinity is the highest. Any questions on that one? If you have them, ask them. Oh, there's one more question. What is the minimum value on this graph? Okay, looking at this graph, minimum means smallest. So what is the lowest point possible on this graph? Right here. That answer is not just the number -3. That answer would be over 0 spaces and then down 3. You'd have to write it like an ordered pair. Okay. The other thing that I might ask you on a question like this, I didn't on this problem, but hold on, let's scroll down and answer that. The minimum was at 0, -3. I sometimes will ask you about the intercepts. So on a problem like this, if I asked you for the y-intercept, that's the only dot that touches on the y-axis. So you'd say 0, -3 for your y-intercept. If I were to ask you for the x-intercepts, there'd be 2 of them. One of them would be over here at -3, 0. That would be one of your x-intercepts. And your second x-intercept would be this dot that crosses the x-axis, which is at 3, 0. So there would be 2 possible x-intercepts. Again, I didn't ask you on this one to find those, so it wasn't actually part of the problem. But I want you to be aware that it could be a part of the problem on the test. Okay, let's go to problem number 8. We are moving right along. On number 8, asking about the x and the y-intercepts. So let's get this one sketched on here. I'm going to start by looking at the y-axis. Here's the y-axis. I'm going to draw a dot at the one place that a blue line crosses the y-axis. That's the only spot. That is over 0 spaces, but up 1 space. So when I come down here, I go over 0 spaces, up 1. That's my x-intercept. But then when I talk about the y-intercept, oh my gosh, I just said x-intercept. That's not the x-intercept. Hold on. That was the y-intercept. Here's how I know it was the y-intercept, because it's on the y-axis. So on the y-axis, it goes over 0, up 1 space. So I'm going to do that on the y-intercept here, over 0, up 1 space. So let's talk about the x-intercept now, the real x-intercept, not just me talking poorly. I'm going to go on the x-axis. That gets really close over there. Do you see how that blue line is super duper close to the x-axis? But let me be real with you, it's not crossing. So we can't mark that as a dot where it crosses the x-axis. Okay, it doesn't, nothing here, no crossing, no crossing, no crossing. It gets really close, but it doesn't cross over there as well. Guys, there are no places on the x-axis that we can see where this blue line crosses. So when I go to do the x-intercept, there were none, because there was no place where the graph crossed the x-axis. If there had been a place, then I could mark it. So something to be careful about. Some of you panicked when you saw this problem. You said, 0, 0. Look at 0, 0. Is there a dot at 0, 0? No, there's not. So please don't choose these things that I put on here to confuse you, okay? I shouldn't say to confuse you, to make it so there's more than one option. Okay, so let's, hold on. Let's look at another problem. Let's look at problem, I could probably clear that out. Let's look at problem number 9. This one is a great example for this question. Is this continuous or discrete? You can tell because there are breaks all throughout it. This one is definitely discrete. That's because the domain is going to have 1, 2, 3 breaks throughout. Okay, so when you have a broken up domain or range, that is going to make it a discrete function. So identify the y-intercept. Hopefully you're realizing how sneaky I was here. There's a reason I didn't ask about the x-intercept. So let's just find the y-intercept first. The y-intercept, it's where the blue graphs cross the y-axis. Bam, that's the only place. There's one place on this whole graph where it crosses the y-axis. That coordinate is at 0, 0. So let's find it and mark it as 0, 0. But look at all these other options. What are all those options? Well, I want to talk really quickly. What would the x-intercepts be? So go on the x-axis. Where does it cross the x-axis? Where's the first place it crosses the x-axis? Well, right over here. What would that coordinate be? -6, up, 0. That's one of the x-intercepts. Okay, keep following along, follow along. Where is the second x-intercept? Oh, 0, 0. Okay, here's the third x-intercept. Oh my goodness, at 1, 0. And then there's actually a fourth x-intercept. Where is that dot though? There's no dot there, but the graph crosses there. That means that there is technically a dot there. That is 5 spaces to the right and 0 spaces up, 5, 0. So there are technically 4 different x-intercepts. And it's okay that one of the x-intercepts is actually the same as a y-intercept. That's life, it happens. Okay, so let's talk about the maximum and minimum points next. Maximum point on this entire graph would be the highest point on the graph. And that highest point is right up here at the very top. Don't let these other points fool you. They're losers compared to that top highest point. So where is that highest point? Well, I have to go to the right 3 spaces, up 4. So I would write my ordered pair as 3, 4. Let's make sure that that's an option down here. Maximum, 3, 4. Bam, done with the maximum. Minimum. Minimum is going to be the lowest point possible on the entire graph. That would be all the way down here. This is the lowest spot on the entire graph. That ordered pair would be to the right 6, down 2. Let's make sure that 6, -2 is an option. 6, -2. Perfect. Question number 9, answered. All right, if you got questions, make sure you ask them in the chat feature. Otherwise, I'm going to move on to question number 10. What a lovely looking graph. On this graph, it's first of all asking if this is continuous or discrete. There are no breaks in this graph, so it is going to be continuous. Okay, what is the domain of this function? So domain, like we said before, is how far that this graph has for its input values, the left-right distance. So this graph, the lowest x value it has, starts right over here at the very beginning. That first dot is 0 spaces over. And then I can keep following along, keep following along, keep following along. And then how many spaces over am I at the very end? What is this counting by? 1, 2, 3, 4, 5. So I think it's counting by ones. So that goes to 30. 1, 2, 3, 4. I can count. 34 is the furthest right it goes, and 0 is the furthest left that it goes. So my domain is going to have 0 to 34 as its option, right here. Then the range is going to have, what's the lowest that this graph goes? Let's go right, let's see. Oh, I'm starting to remember. I think I definitely got this one wrong the first time, and Mr. Bodley had to correct me, because the first time I did this one, let me tell you what I did wrong. I said that this range was from 0 to 11, 12, 13. I said the first time I did this problem that it goes from 0 to 13. Can you figure out why this is not 0 to 13 for the range? Why is this not 0 up to 13 for its highest point? Sometimes we're tempted to just look at the graph and say, oh, 0 is the lowest space on the graph, and then the highest dot I can see is over here. That's a problem because this graph doesn't actually go down to 0. Look at where this graph goes down to. This right here is the lowest point on the entire graph. but that's not 0 spaces up. That's 2 spaces up. So I know that my graph is going to have to say that the lowest that it goes on the range is actually 2. That's the lowest space it goes down. Now let's find where the highest point is on the range. This dot up here is the highest point, not this thing over here. So that dot is about 15. So I wouldn't be able to say 0 to 13. I would have to say it starts at 2 and goes up to 15. That is going to be the range on this thing. Oh my gosh, I did all that work and it didn't even ask about the range. Wonderful. Okay, but let's talk about the minimum instead. So the minimum point on this entire graph, oh my goodness, I can't believe I just did that whole problem. The minimum point on this whole graph would be this dot right here. That's the lowest dot on the entire graph. I go to the right, 10, 11, 12, 13, 14 spaces up 2. So the minimum is 14 spaces to the right, 2 spaces up. 14 to the right, 2 spaces up. Okay, I actually do want to talk about one more thing that's not a question on this problem, but there's only one problem after this, so this is going to be helpful because there's one like what I'm going to explain on the test. Okay, so let me clear off what we've got so far. And I want to ask you, over what interval is this graph increasing? Where does this graph go uphill? So if you're thinking, it doesn't go uphill over here. This is all downhill, downhill, downhill. When you're going from left to right, it's going down, 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 bam. This is where it changes direction and starts going up. Uphill, 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 uphill. This isn't going as fast, but it's still moving up right now. Up, up, up. I don't actually know exactly where this turning point is. Let's just assume it's right here at 31. So if I asked you what interval this is increasing, you would have to say this entire section is increasing. And there's a problem like this on the test where it's curved, but it can still be increasing. So this thing starts increasing 10, 11, 12, 13, 14 is where it begins increasing. And we've talked about how it could be an open parenthesis or a box parenthesis. I'm just gonna go with box because I don't wanna confuse you with coordinates right now. And then to the right, it's at 30, 31 is how far to the right. So if I had to say that it was increasing, I would say along that interval from 14 to 31. And then if I said decreasing, I would have to talk about 2 separate intervals. I would first say that this section decreases. And yes, you could call that one whole interval, even though it changes rate, that's fine. And then this tiny little section over here, it also decreases. So lots of different intervals. We can still talk about them even if they are not a constant rate of change, which would be a straight line. Good question. I just got a question that said, are there going to be confusing decimals with this kind of problem? Good question, Liz. No, it's going to be pretty obvious where the starting and the ending point is. So I think what Liz is talking about on this problem, do you see how this was a confusing kind of guessing point? They are going to be pretty guessable points. And even if, let's say for example, I was a total jerk and I wanted you to actually guess this. When you click this drop down thing, whatever the decimal is going to be an option in here. So it might say 31.5. That's great. There's not going to be a 31.6 as well. There's going to be one obvious answer if you can see what area it's in. So don't get too worried about that. I'm never going to say, hey, guess what this random dot is on the whole graph and type it in to make sure you guess it correctly. That would be a total jerk move. And we did not choose to be jerks on this test. Okay, we have one more question, and I know you missed my lovely singing, except all of you who don't have me, in which case you just think I'm a weirdo, and that's okay because it's kind of true. Okay, so let's talk about this last section. Is the function continuous or discrete? Obviously, bunch of dots all over. Continuous or discrete? This one's going to be discrete. There are dots everywhere. That is broken up. It is a discrete problem. So then let's talk about this last part, f of 2. This is that thing that I told you to write on your notes up above, where I said f of the input equals the output. So that means f of 2, my input is 2. That's my x value. So I am going, thank you, Mr. Bodley. He said it's definitely true. When I look at my input, it's right here, 2. And how far up to get to the output? Bam, there's my output of 1. So it's saying when I go over 2 spaces for my input, I have to go up 1 space for the output. So I should get 1 as my output. Bam, it's one of the options. Yay, we won this quiz. Let's see how we did. I don't actually know what happens if I push submit. Maybe it tells me I got a score. It does not. Okay, whatever it did, that's great. Oh, we got 29 out of 29. Perfect. So if you have not taken the practice test yet, that was not a great choice because now you're just gonna have to go take it, but we have gone over every problem. If you are feeling like you're ready to take the test after going over this stuff, that's awesome. I will link all of this stuff and I will be opening right now. It is 2:20. I am going to upload this video onto YouTube, and once I have it uploaded, I will link it and you will be given the option to take the test. Otherwise, it was wonderful to